In question 5, we're told that Rowan has a large number of cubes. Some are red, some are green, and the rest are blue. Rowan performs the following experiment. He picks 5 cubes at random, he records the colours of the cubes, and then he replaces them. He repeats this process 7 times. In the table that we're given, the 7 trials are labelled with the letters from A to G. Looking at the column of an individual trial tells us how many cubes of each colour there were. For example, in trial D, there were 2 red cubes, 3 green cubes, and 0 blue cubes. In part I, we must work out the mean and standard deviation of the number of red cubes. Well, looking across the 7 trials, the number of red cubes were 0, 3, 2, 2, 4, 5, and 1. We'll need to find the mean and standard deviation of this data. Thankfully, modern-day calculators can find these quantities for us. If you go to statistics mode and type in our data, then the calculator will return the mean and standard deviation for you. Rounded to 1 decimal place, the mean will come out as 2.4 and the standard deviation will come out as 1.6. If you want more details on how to do this calculator work, check out the video linked in the description. In part 2, we must work out the correlation coefficient between the number of red cubes and the number of green cubes. Again, this will boil down to calculator work. This time, there'll be 2 lists of data we'll need to input. For the X data, we should put in the values for the number of red cubes. 0, 3, 2, 2, 4, 5, 1. For the Y data, we should input the values for the number of green cubes. 4, 2, 0, 3, 0, 0, 2. Once you've performed the necessary steps, your calculator will return the correlation coefficient for you. Rounded to 3 decimal places, it comes out as minus 0.762. In part 3, we're told that Rowan repeats the experiment a large number of times. We must explain why we would expect the correlation coefficient between the number of red cubes and the number of green cubes to be negative. Well, the core idea behind a negative correlation is that when one quantity goes up, the other quantity will go down. In this experiment, Rowan picks exactly 5 cubes on each trial. This means that the red cubes plus the green cubes plus the blue cubes must be equal to 5. If there's a large number of red cubes, then there won't be much space left over for the other 2 colours. This means we'd expect a small number of green cubes. As an illustration, if the number of red cubes was 5, then there's nothing left over for the green cubes and blue cubes. So if red cubes equals 5, then it must be the case that green cubes is equal to 0. Since larger numbers of red cubes correspond to smaller numbers of green cubes, we have a negative correlation between the 2 quantities. In part B, we're presented with a cuboid that is made up of a large quantity of small cubes. The width of the cuboid is 5 units, the height is 4 units, and the depth is 3 units. We are asked to consider the number of faces each small cube has exposed on the outside. As an example, the cube in the top right corner has 1, 2, 3 faces on the outside. The task here is to count up how many small cubes have 3 faces on the outside, how many have 2 faces on the outside, how many have 1 face on the outside, and how many have no faces on the outside. One of these values is filled in for us already. We're told that there's 22 small cubes with 1 face on the outside. So, if we're trying to look at the cubes with 3 faces on the outside, you'll notice that this only happens at a corner piece. I've coloured these in purple in the diagram. There's 4 corner squares on the top layer, and there'll be another 4 corner squares on the bottom layer. It's worth pointing out that one of these corners is hidden from view in the diagram. 4 plus 4 is 8, so we end up with 8 small cubes with 3 faces on the outside. The cubes with 2 faces on the outside correspond to the non-corner pieces which appear along one of the edges of the cuboid. I've coloured these in orange. If we focus on the top layer of the cube, we have 1, 2, 3, 4, 5, 6, 7, 8 orange cubes. By symmetry, there'll be 8 orange cubes on the bottom layer. Focusing on the 2 middle layers, you'll notice we have orange cubes stacked in towers of 2. 3 of these towers are visible. 1, 2, and 3. There'll be a 4th tower hidden behind view below this back left corner. Each of these towers contains 2 orange cubes, and we have 4 of them, so this gives us 4 times 2, which is 8 orange cubes across the 2 middle layers. 8 plus 8 plus 8 is 24, so we end up with a total of 24 cubes with 2 faces on the outside. The only thing left is to find the number of small cubes with no faces on the outside. Well, the dimensions of the cuboid are 5 units, 3 units, and 4 units. The total number of cubes will be 5 times 3 times 4, which is 60. We've already found the number of cubes with 3 faces, 2 faces, and 1 face on the outside of the cube. The number of cubes with no faces will simply be the leftovers that are needed to make up a total of 60. We can find the leftovers which are needed by subtracting each of the other numbers from 60. So we get 60 minus 8 minus 24 minus 22. This comes out as 6.